So Ian, I'll just hand over to you and let you carry on, and we'll hear from you, and thanks so much for doing this for us. And I'll turn my video off and mute myself.
Okay, well, here's hoping that it all works out. Okay, right, my talk is to try and convince you that caddis are interesting. And that's the organisation I'm from. I'm now calling it the British Caddis Recording Scheme because I don't cover Northern Ireland. So British is a better term for it. It's part of the Biological Record Centre recording schemes, and I'm associated with the World Museum, Liverpool still, and the Freshwater Biological Association. Now, caddis have, well, everybody knows they've got fascinating, conspicuous, well-known larvae. And rather, well, some people would think uninteresting and inconspicuous and not so well-known adults. That's me, basically. You'll detect I've got a northeast accent because my wife's from the northeast of England, and I think you tend to keep your accent that way. My mother-in-law is in a care home now, and thus I haven't got any base in the northeast of England anymore, but I can visit you virtually as for tonight's talk. Now, I think they're interesting. It can be actually very exciting, and I do want to show you, just give you a preview of my next project that I'm still working on, where show caddis are very exciting. That's what I'm hoping to finish that soon. But seriously, I do want to show that even though they might not be tremendously exciting, they are at least interesting. So what makes an interesting insect? Well, see, to me, you might say, that's an interesting insect. Look at that, it's got an interesting of the positive. It obviously sticks it in something, and there's hundreds of them. It's obviously very interesting. It does interesting things. The trouble is, we don't know much about it, really. I'm gambling that there isn't anybody in the audience who's an expert on that. But we don't know much about that particular insect. Or there's some cocoons of a little chalcid. We don't know what the species is. We don't know what it is. It's been parasitizing. We don't know much about it. Now, of course, DNA technology is going to make something like that easily identifiable. But not very interesting insects, I think, because we don't know much about them. Radical difference from that. Obviously, there's a broad-bordered yellow underwing, so the caption told me, and the parasites which have come from it. So that's interesting because we know something about the biology. And that's why caddis, in a way, are interesting. Take beetle like that, again, and a theta. Well, somebody in the audience might say, oh, well, of course, that's X and it does Y. But well, we don't know much about its biology, its ecological impact. So is it less interesting? Or actually, is it very interesting because it's a great challenge to find more about it? Or the famous flies which relate, which people, have described sometimes as horrid foreids, which we don't know much about the larvae. So what's the ecological impact? Unlike caddis, as I was saying, where, we know what the larva is for 191, and the other 10 are the microcutters. Yes, caddis are quite closely related to Lepidoptera, and as a Lepidoptera, we've got these dreaded micro Lepidoptera. We on the caddis side have our Microtrichoptera, but that's where the 10 are missed. But we know the ecological impact because we know what the larva is doing. So I would say that makes them more interesting. But you could say it makes them less interesting because there's less to find out. But anyway, let's get back to some basics about caddis. Where did the caddis come from? Well, they reckon they've been around for quite a long time, 250 million years ago, and they were certainly quite well established 230 million years ago. They are allied to the Lepidoptera, so it's always the bit, well, are caddis moths or moths caddis? And the answer is they're neither. You can look at something like the birds and say, right, the dinosaurs, our ancestors ruled the world. For the caddis and the moths, their ancestors lived in moss, so perhaps not quite so dynamic a past. But that is the root order to which both caddis and moths belong, the Amphias Menoptera. That's what they look like, and yes, it does look a bit like a caddis, and that's from the Baltic amber. And it's thought they lived in galleries among moss and algae right at the water's edge, and the galleries were reinforced with silk. The adults had hair-covered wings to trap air. And silk was the key to their success. And I'll mention silk again because it is the key to the success of both caddis and Lepidoptera. Right, so these ancestral Amphias Menoptera, and that's actually, it's translated as dressed up wings, reflecting the fact that the caddis have got hairy wings and the Lepidoptera have scaly wings, but it's the hairs or scales give them the colour. In other words, it dresses up the wings. And that's what they led to, those two sister orders, but they are quite separate. And silk was important, as I said again. Silk is the feature which has enabled both of these groups to do quite well, especially the caddis, enabling the larvae to be the most diverse of all the freshwater groups of insects. Now, when I say choices, I mean evolution. You don't actually make a conscious choice, but there were two possibilities afforded to Trichoptera and Lepidoptera, I suppose. You could stay with the generalized diet. Now, the useful thing about the generalized diet is there's usually always something around for you to eat. And that's the route taken by the caddis. But that meant that they've only got 13,000 world species. Radically different for the Lepidoptera. Okay, you can specialize on feeding upon one sort of plant, and the plant can try to evolve things to fight you off, but generally you can be specialized. Now, I know there's generalized feeders of Lepidoptera as well, but they're all going to be feeding upon the plants. They're not going to be feeding upon a wide range of other things as well. But that leads to 174,000 species, a specialized diet. It's just an aside, it's very interesting how very few things actually eat live freshwater plants. That's a China mark moth, a Lepidopteran node, and they will eat live freshwater plants. It seems as though freshwater plants produce active chemicals. Well, in fact, it's known they produce active chemicals which deter other things from feeding on them. But it's just an interesting observation. Right, the groups of caddis. There's basically the larvae which make a fixed shelter, and they're generally called the caseless caddis. That's because they haven't got a portable case. Then there's a group which does have a portable case, the case caddis. Then, as always in so many evolutionary groups, you've got others. The newly Palpia are the caseless caddis, the invertebrate Palpia are the cased, the spigot Palpia are the caddis. And you might say to yourself, what actually, why are you calling something whose main characteristic is that it's got a caseless larva? What's this got to do about palps? Palps are sort of something on the adult head, what's going on? And it's all to do with the fact that when you're trying to find common features which will connect groups, you keep paring them down, getting rid of features which have evolved, and then eventually you end up with some character which does seem to be held by all members of a particular group. And that's this thing that the newly Palpia, who've got flexible maxillary palp ends, the case caddis have got not flexible ends, and the others, the spigot Palpia, have a little point at the end of the maxillary palp tip. Now, I have no idea what the significance of these are. Is it just something which is hanging on from evolution? That's it just inert things, but I tend to not believe in inert characters. Whatever it is, we don't really know what the significance is what an Palpian can do that an Palpian can't, or vice versa. But that's why they're called after after the adult pulp rather than the larval form. And just to, as I said, caddis are interesting. You can see caddis are very interesting. You know, I mean, you can see why caddis are so interesting. No, only joking. But that's how it's now thought the interrelationships of the caddis fall. And it's interesting because everybody knew about the cased ones as being separate and the caseless ones as being separate. Nobody could really fit in the others in the middle. And DNA work has shown that actually the cased ones are probably, you know, polyphyletic of origin, and in other words, they're not necessarily related closely to each other, but they are related to the case caddis, not to the caseless one. And that's only been the past few years that I think that conclusions has been reached. And these things do, you know, you can still work out on these things here, you know. For example, that group of the case one would be the limnephalloid group, that would be the ceracostomatoid group, and that would be the leptocerid group. When we talk about some of these features, well, here's something interesting. You know, you might say, well, a feature of caddis is that vein M4 and vein CU1A are not fused, which they are in the Lepidoptera. Well, it does enable the wing to fold in quite a nice way, and most caddis rest in that way, with the sort of anal area of the wing folded over, and that is one of the features. I know there are plenty of moths who also roll their wings up, but that is a feature of it. So let's get down to some of the biology of the caseless caddis first of all. They're interesting because the caseless caddis groups quite distinct, easy to tell apart, more so than it is to try to separate the families of the cased caddis, but the caseless ones. That's the first of the group I'll cover, Hydrocycle. They, when they're talking about shelter makers, a fixed shelter, that's where the larva lives. It makes that out of silk, to which it uses to bind particles of plant material and sand grains and so on. And that's where it lives. But at the front of that shelter, it constructs this mesh net, and the current flows through there, and things carried by the current get caught in the mesh, and out comes the larva and gets hold of them, of whatever's landed in the net, and takes it back and feeds on it. They only make the net when there is enough floating in the water. So over winter, you may not make a net at all, and you may in fact graze, because the great thing about fresh water, the great marvelous thing about it, is because everything's wet, you get a lot of things growing on the rocks, algae, bacteria, and so on. So I mean, you know, on land, a bare rock surface hasn't got much to eat on it, but underwater, you'll get a lot of things growing on the rocks. And that's what these larvae will feed on during the winter, when there's not much floating in the water. And of course, the other thing, it's this advantage of being the generalized feeder. The other thing is that you have to be fairly, well, happy to eat more or less whatever lands in your net. Of course, like many things, they would much prefer it were animal, you know, a highly packed bag of food like an animal landing in there is better than, say, a dead leaf. But they can manage on, almost all the species can manage on anything. So that's the Hydrocycle. It's unmistakable with the rows of the fields. Getting the caseless caddis to a family is really not a problem. Next group I'd like to deal with would be the Webmakers, the Polycentropodes. Now, these are the nearest equivalent to an underwater spider. I know there is genuine underwater spider, but these ones make webs, and that's the web underwater. you're likely to see this best in sort of upland streams, where if you see what looks like a net with a hole in it, the nets tend to catch, as well as catching things floating in the water, they will also trap a lot of debris, and that's why you can see them. You can play with these things actually. If you find one of these and you tickle the grass stalk in the entrance, and just like a spider, the larva will rush out and grab you a bit of grass. Because these are predators, and that is where they live, in the retreat. And this is a very amorphous sort of web, beautiful underwater, but when you pick it out, a little bit like the Hydrocycles, it's very rare for you to ever be able to see the form of the net because it just collapses. But of course, you say, well, you know, or they're only feeding upon you know, what they can filter out of the water. But increasingly, we realise that actually things grow on these nets. So these generalised feeding larvae can feed on other things which are growing on the net, and that's where this is not a common species in your area really. It's called the Microcutters, and it makes like a funnel, a bit like a French horn, and water flows in there and gets sieved out on the rest of the tube. Seems nice and easy and straightforward, but in fact people now find that in fact a lot of the feeding of these is what are the algae and things which actually grow on this silken mesh that you've made. So again, being a generalized feeder enables you to be feeding throughout the year, and with any luck, you won't starve. The next one of the cases, the Sockmakers. Now they are interesting because they are found in the fastest water, and their mesh is very, very fine indeed. So it is catching very fine particles which are being swept down by the current. That's if you pick out a rock which has one of these Sockmakers on, that's what it looks like. And when it's out in the water, these would have an emergency escape reaction, which is that they will cut a hole in the bottom there and zoom out and escape. But these were one of the first ones. When you look at these ones, that's quite a clean one, but often the only bit which is actually not mucky is the very bottom end, and the rest of it is really mucky, covered in silt. And people think that in fact a lot of the feeding is by scraping off what is grown on there, as much as what has actually been filtered out. All the larvae are strange in that they all have a sort of a white or green body and an orange head, whatever the genus is. But that's the Sockmakers, and they're making all these nice nets to sieve stuff out, or in the case of the Polysyndepholius, catch them like a spider. But different, this one is the next one. Suppose this is in a way possibly the very early Amphias monopteran larvae in their galleries in the moss might have looked something like this. But it takes a while for you to get your eye in for these things. But if you pick up a rock from a stream, and it seems to have these meandering galleries on them, and if you brush your finger very carefully over the rock surface, if those galleries have been made by a midge, a chironomid larva, then they'll be dislodged and swept away because the chironomid ones are quite weak. But if it's made by one of these Psychomyas, the gallery-making caddis, you won't be able to rip it off. The larva lives in this gallery, and it used to be thought that what it did was it grazed the algae at the end, and that is true. That is what they do. But as well as grazing from the end, so therefore, when you run out of food at the end, you just extend the gallery a little bit more and a little bit more, avoiding running into the gallery of your next-door neighbour. But that is one of the ways which they feed. But then people start to realise that actually, what you've got there is actually a bit like a greenhouse polytunnel. Light gets through the walls of this, which is made of silk and small sand grains and things like that. But light gets through, and algae can grow on the inside, fertilized by the nitrogenous excretions from the larvae. So it's a good place if you're an algae to be living in there. Well, I suppose until you get grazed off by one of the larvae. But certainly it's appreciated that quite a lot of the diet of some of these can come from the algae growing on the inside of the case. One form, Larvae, lives on wood, and it actually it genuinely chews through the wood. But, and this is a very interesting thing, they don't have digestive enzymes to digest wood. They've got digestive enzymes to go for fungi in particular, and the bacteria to a lesser extent. So in other words, what this is doing is digesting the fungi and bacteria which are rotting the wood. It's this difference between ingestion and digestion, and they're quite difficult to spot, Larvae, but once your eye is in for them, so if you want to pick up bits of wood and logs, you might often see this sort of, again, is rather, it looks like a mass of small droppings, small wood chippings and sawdust stuck in a gallery along the wood, and that's what they are. That's Larvae. So an intriguing group of caddis. It takes you a bit of time to get your eye in for them, but once it's in, you can find them all over the place. So there's ones, they're all making use of the silk, and that's the caseless ones. So let's get down to the case ones. Well, right. The great thing about case caddis is, oddly enough, the case. Now they aren't all British, those cases, but most of them we have the equivalent in Britain. We haven't got that. I wish we had that, which is one Hydrocycle, which make a case looking just like a little snail shell. But we've got most of the others. We have caddis making cases like most of those ones, and you can see basically they've used a wide variety of different materials. Some, a minority, don't add anything to it. It's just pure silk. This silk makes the entire case. But most of them, the silk is used to stick other bits together. Bits which you've either found generally, things like those, more, in other words, you're not very selective about what you make, and those are attached longitudinally. Apologies for that. Whereas those are attached transversely, and you're probably very familiar with that one particular, and it's very sad that in fact there's a whole suite of species, and you've got to really get a microscope and probably a dead larva to get to the species. But anyway, those are bits cut in. Sometimes you cut pieces very carefully to length and join them up in rings. You can use sand grains, you can use old shells, and it's the variety of the cases. And some caddis you can identify from just the case alone. But you have to remember that the case, it's not actually physically part of the larva. So for example, if one of these caddis loses its case, then it'll make an emergency one afterwards. And if you deprive, say, that caddis of little sand grains, it will make a sort of case out of bits of plant material. So they're not absolutely 100% guaranteed to enable you to name a caddis to a species, but they're reasonably good. So what is this case? Well, the caddis has an inner smooth tube of silk threads. It's nice and smooth in the inside, and the items which it's selected or cut and whatever it is are attached to the outside of the inner silk tube. And the caddis case grows from the anterior end, so it adds stuff on at the front end, and then after a while, when it's outgrown the rear end, it may well turn in its case and cut the rear end off. But that's basically it, an inner smooth tube with material stuck on the outside. There are variations. You know, sort of the strength of plywood is that it has different layers, and that's what makes plywood really strong. Well, there are some caddis, these ones here, add an outer layer of silk outside of the particles. So you've got your inner silk tube, then your particles, then silk on the outside. And they are very strong cases. Strong to, you can't snap them easily. You can't chew them and crush them. It must be some protection. But the interesting thing is, both of these two live in quite unstable environments. And the strength of the case, I think, is not against something eating them, but actually because they might well be rolled around in a flood, and gives them some protection. The other one, which is the silver sedge, it chooses very carefully. Every sand grain is carefully selected, and it's chosen around and it's moved around, and then with silk, it mortars it to the next sand grain to it. And it also has to choose the sand grains very carefully to make sure that it doesn't produce a rough inside the case. So very strong, those ones. It's been proved that they are that they're more difficult for a fish to chew them and crush them. But if they do get crushed, they break catastrophically. The case, the caddis which have an inner silk layer and the particles on the outside, that there's a certain amount of flexibility of those. And if it's bent or crushed a little bit, it can bounce back to a certain extent. These ones, if it's broken, it's catastrophic and they have to start again. There's also a lot of effort involved in the careful mortaring of all these bits together. So when I was saying that the case are more uniform, well, they're not the so strongly marked morphological groups as there are in the caseless caddis, but the case caddis are certainly by no means lacking in interest. Let's say the materials added at the front end and the old case can be grown up at the end, and they can't build a new case if they're evicted. So what's a case for? Well, protection against being chewed, I've mentioned that. Against being washed away. These ones have the so-called ballast stones, the Glossady, and those ballast stones are supposed to help it not be washed away in a flood. They also, it's found, the other time you want to avoid being washed away is if you want to feed in an area of fast current. And these things, the larvae of the guerids, graze algae from the surface of stones, often where there's quite a lot of current. Now, you've got two options. You either hang on for grim life, but that takes energy. So if you have a heavy case, that just by gravity can stick you down onto the surface of the stone, reducing the amount of energy you have to use. But of course, you've used more energy to build a case like that in the first place. But overall, that's what these ballast stones are. They're not just to stop you being washed away in a catastrophic flood. We certainly think that the protection against being swallowed. For example, the way that a fish, people know, fish feeds, comes up and then it drops the roof of its mouth and in rushes the water, carrying the caddis with it. But if in fact you can't get near the caddis, for example, if you can only get your mouth as far as there, you're more likely to fill it with a mouthful of water than you are to fill it with the caddis larvae. And it's thought that these ones with these cross bits, it's not just for camouflage, it's for to make them more difficult to be swallowed. Camouflage is certainly an example. This is Melana, which has puts a flange of sand grains around the main case. There's the main case, and there's the flange around the outside of sand grains. And there's some on a sandy bottom. It's one of very few caddis larvae which actually live on the bare sandy bottoms of lakes and ponds. And again, everybody thought this case here is just all about camouflage. You know, that's what it's all about. And certainly they move in leaps. In other words, they'll stay still, and then if they want to move, they'll jump forward and settle again. So it's sort of like, you know, obviously fish can't see these, or it's more difficult for the fish to suck them all up. It's all about camouflage. But then somebody watched them carefully feeding, realized that actually it's also part of a very clever feeding technique. If you imagine you were on there and you were in there, there's the flange, and your head and legs are working around in the substratum about there, and you encounter a worm or a chironomid larva, right? Normally they would diddle off, you know, straight away, but you've got a good chance instead they will shoot up and get trapped by the flanges of that, enabling you to sort of easily catch them. So again, it was one of these cases whereby, you know, a simple, obvious conclusion you might reach about why they had a flange case like that wasn't entirely all the answer. It helped them in feeding as well. The cases have one of their principal functions, and this is why when you look at the distribution of the caseless and cased in running and still water, there's for obvious reasons a higher proportion of caseless ones in flowing water, because you need the flowing water to carry the food into your nets. But that's not the entire story. The caddis is designed for passing and pumping water through its case. It's got those lumps there which will hold it, fleshy lumps which will hold the body in the middle of the case. It's got a hair fringe on the side which effectively isolates the top and the bottom of the case, and by undulating the body, water can be drawn in and passed out through the rear end. So improving oxygen supply is another important feature of the case. Of interest, you notice the rear end usually is quite small. And the reason is because enemies can get in, not big things. The main enemy are in fact predatory predatory midge larvae, can creep their way in there and attack the soft rear end of the caddis larva. So many caddis larvae have also got very strong hairs on the rear end. Sensory as well, yes, to tell when you're near the end of the case, but also to probably try and deter, like a sort of a palisade against these little midge larvae getting in. And some of the just sideline. Brachycentrus feeds a bit like it fixes its case onto a rock and then holds its arms out to catch things flowing in the water. So it's living like Hydrocycle, for example, but it's a fully cased larva. Intriguing species this, in that it used not to be found in the River Tyne at all, but the Keeler Reservoir, which is obviously a good source of stuff floating down, you know, lake material floating down the river, now has a very good population of Brachycentrus. When I was doing my studies in the mid-1970s, Brachycentrus was in the Tees, but not any of the other northeast rivers, and now it's doing okay. Right, the Spigger Palpia, the last group that I was talking about. What about those? Well, they certainly seem to show a number of primitive features, but you know, remember that the main original split was between the caseless and Palpia and the Integra Palpia, the cased and Spicipalpia group. This is Rhycophila. It doesn't make a fixed shelter, doesn't make a transportable case as a larva. It's a free-roaming predator. When I say free-roaming predator, again, people had visions of this thing just, wandering around wherever it wanted to go, and just ending up wherever it did. But no, these tend to have a home stone, and they will have silken threads, and they will, which will guide them back to the home stone under which they will rest during the day. Because, I mean, fair enough, fish are more easy, you can see things more easily in the daytime. So that's what it looks like. But then when it wants to pupate, it gathers together bits of pebbles and large sand grains and fixes them on, and then underneath that, and this is one turned upside down, you've got this little bean-like cocoon made out of silk, and you pupate inside there. That's a primitive feature. Many of the things about this are primitive, and in fact, in the early days, people spent a lot of time trying to evolve cased and caseless caddis from something like Rhycophila. We now know that the DNA shows that isn't the way it went. But this is a group, they have retained their primitive features. The main thing thereafter, when I say predators, it'd be, we haven't really got caddis larvae sort of, leaping around in the water like a lion or a tiger, jumping on things. You either wait for something to get caught in it in your net, or in the case of Rhycophila, one of its favourite foods are Simulium, the black fly larvae, which are fixed in their filtering ways, and these things can grow amazingly fast on this high protein diet. The other group of the Spicipalpians, one of the other ones, are the Glossosomatidae. Now, these are the ones, you all know these. You look in the stream and you find these little things like little tortoises all over the rocks. The larva lives inside there. It's grazing the alga from the surface of the stone, and it pupates rather like Rhycophila. It just fixes that case onto the rock, takes the bottom out, and makes a little bean-like cocoon inside. Abundant things, really good. They're odd in all ways, although they're, you say, well, case caddis, so obviously related to case caddis, but it's a very funny case. Everything's odd about this thing. They actually make a brand new case. When they molt, it'll prepare, first of all, a brand new case still attached to the end of that case. It'll then molt and then cut the old one away. It doesn't undulate its abdomen to carry water through it, more like a stone wall, a dry stone wall, and the water blasts through it. So they need a good water flow, flowing water, or very large stony lake shores like Windermere and Ullswater. And then I mentioned the micros. You see, those are full-grown micro cases. So you see, they are rightly called Microcutters. They are small, and it's among this group that we have some of the species whose larvae we do not know. So we don't know their life cycle. They are genuinely the least known of all of the caddis. Very strange, these things. All the Spicipalpia, all this sort of the other caddis, they're all odd. They do odd things. The newly hatched larvae are completely free living, and they wander around feeding mainly upon algal filaments. But then the final instar, they then molt and then make a case out of silk. Usually it's laterally flattened, and the larvae become very fat and large in this case. Then pupate in it and emerge as these tiny little adults. But Microcutters is a good name for them. So I've tried to show you, I hope, that larvae do interesting things. So do the adults do interesting things? Well, yes. Courtship and mating involve interesting behaviour, but too often it takes place in the dark. So all you see is that. The day active ones are easier to observe, certainly. You get horizontal zigzag swarms of things like the Leptoceras, using a particular location marker on the bank. So this swarm acts, as are all swarms, they're based around some locational feature of the environment. So they're ones you will have noticed, those ones over still waters and over rivers. Sometimes some of them have an up and down swarming motion, and that first lot, this lot here, those two, have, I think, one of the best examples of testing male fitness that I know, right? The swarms are of males, and the females approach the swarm, and a male will shoot out and grab hold of the female. She will then stop flying, and he has to carry her ashore. He has to carry her to something on the bank, a leaf or a twig or something, where they can then finish mating. Should he fail and they land on the water surface, she will just break off, use all her efforts to break off, because he has, in all real sense of the term, failed the male fitness test. Unlike these ones, these collaborate, both male and female of this Mastocides longicornis, which does the up and down flying, participate in getting ashore. The interesting thing is these are also active at night. So how on earth do they actually see each other? There's a lot of mysteries about caddis. Quite a lot of other caddis, the males sitting there, they aren't all jived up. They're absolutely ready to go. As soon as they get a little whiff of the virgin females around, they will then shoot up and form this swarm, desperately trying to sort of find the female. The little micros, there, the female sets off, runs round in zigzag circles, and the male has to chase. And no doubt the male that gets there first gets the female. Pheromones are certainly probably involved for a lot of species. The female produces scent for the female. There's another one where the male will wait for freshly emerged females. So the interesting thing is, if you go sweeping for these at the water edge, you get almost all males, because the females obviously just go and hide. You know what I mean? Once you've mated, you'll then go and rest away from the water's edge. Otherwise, you'll be pestered to death. These ones I like best of all. Agapetus, it's fantastic. It uses pheromones to sort of attract the sexes together. The male does a dance. He makes a sound, and he will chase off other males. So, he might look small and rather dull, but Bikum uses all those features in order to attract the female. The patterns are obviously for, what are they for? Well, avoiding enemies, camouflage. That's it there, resting there. So the wing patterns are certainly for camouflage. Not sure to what extent they also for species recognition, males and females. Interesting thing, anybody starts putting caddis, you will know very well this phenolic smell, coal tar sort of taste that you get. It's got to be nasty, but I don't know of any caddis person who's had a serious effect. Now, you do get where you can have problems, and this happens in North America, where you get absolutely huge numbers of hydrocycles, so many they've got the hairs come off, and people get allergic asthmatic reactions to the hairs. But in this country, no, and the phenolic chemicals, so far we know, no problems. One of the caddis that I'm particularly fond of are the ones adapted to waters that actually dry up during the summer. And the caddis goes away as an adult and rests over the summer as an adult. It rests in ash keys. It's active. It feeds on open nectary flowers, stays active, but doesn't become sexually mature until the autumn, when they mate and come and lay their eggs in this. It lives in a little sphere of jelly which absorbs moisture, so they'll tend to go into things like under logs. The famous one, Glyphos, lays eggs on leaves overhanging where the water is going to come, and they are usually 99% they get it right, that there's going to be water under where the larvae are, because the larvae of these things will either wait in this jelly until the water comes in, or often they will hatch but then bury down without making a case or anything. They'll bury into the damp substratum, waiting again for the water to come in. These will hatch and drop down into the substratum and again bury away until such time as the water returns. And it can be very significant. One of the other features, of course, of waters which dry up over the summer is you don't get fish. So there are not so many predators, but you can get huge numbers. A 12-minute sweep, no, sorry, a 12-second sweep of that particular pond produced about 80 of these large larvae feeding there. And now is the time to go out and start finding these. One of, you might say, what's he giving a talk about caddis when, at this time of year, we know insects aren't around this time of year. Oh, yes, they are. Because in these water bodies, which are just filled up, the food is the dead plant material which accumulated over the summer. And that is an excellent food, but again, digestion and ingestion. They eat the leaves and the debris, but what they're digesting are the fungi and the bacteria which are rotting the leaves. But now is the time to find these. Their main growth time is over winter. They're found in ponds, they're found in streams and rivers, and also in lakes, but the margins. In other words, a lot of lakes have got the margin is exposed during the summer when it drops down, and that ring is colonized by these temporary water body lymphilids. Right. Well, hopefully you're intrigued and would want to go and record caddis. And after all, I'm giving this talk for Eric, the Northeast Recordings section. So let's see if we can get you interested in recording caddis. Right. Just for interest, this rather unprepossessing spot at the bottom of the field is actually a Northumberland site. It's near Netherwhitton, and it was one of these temporary areas. In other words, the bottom of this field probably flooded every year, so you would get particular algae growing on the bottom, and this would be probably the scent cue for the females to go and lay. That's the rest of my of the Wallace family, and we're all keen on looking for caddis. It's quite a few years ago, so my sons have grown up quite a bit there. But that is in genuine Northumberland site near Netherwhitton. But you'll be expecting me to give you this sort of message, forget the rest, recording caddis is the best. Okay, I'm not going to go as far as that, but certainly there is quite a lot of interesting things you can find out about caddis. Well, are they worth recording? Well, people involved in water quality certainly think recording a larvae is very worthwhile. The simplest form is the river invertebrate monitoring for anglers, or the angler monitoring scheme. And in this one, you only have to recognize two sorts of caddis. Is it cased or is it caseless? The caseless did sometimes give problems because midge larvae can look a bit like caseless larvae, but generally you had to just look at them and estimate their numbers. This recording system is particularly good at picking up transitory pollution incidents. It was designed for that purpose. In other words, the Environment Agency, even if it had 5 times more staff than it has now, would still be probably struggling to get enough samples from any river or stream to pick up an incident where, for example, some insecticide had been, had got into the river, killed off all the life, but then the stream recovered. In other words, this is particularly good for transitory pollution incidents. That's the simplest form. The Environment Agency itself then went on to the biological monitoring working program scoring system, and that was working on the principle that some groups, like the flat-bodied upwings, they only lived in really good, fast-flowing, well-oxygenated water, so they got a high score, whereas as did something like that, whereas caseless ones, you got a slightly lower score. I don't know why, but that's the way which it works out. And gamma-rays, you got an even lower score again. You add it and you'd add all of those up, then you'd get a score which indicated whether it was badly polluted or in very good condition. If you add species level, it adds a great deal more value to the records, but it takes more time and adds to the costs. But the Environment Agency has now moved on to species level recording, which is very good. I'm very pleased because that data is more valuable to me on the recording scheme than obviously family level data. But take an example. What I'm getting at is to take an example of these the Hydrocycles here. Right, they would have one score, right? One score for the whole family, but it can cover those from very cool spring streams, those two, to ones which are really found in larger rivers, and even getting down to ones which are found in polluted rivers, Exoslata and Angusta penis. You know, so the average score, which is what that is all about, can be greatly improved if you go to species level identification. Okay, so what about recording adults? Well, the Environment Agency and the Angler Monitoring, they mainly cover rivers and larger streams. So there's a lot of species they never encounter. There was a certain, there was discussion about whether in fact we should call caddis river flies, but it's a very good idea to join caddis, mayflies and stoneflies together, but a large number of caddis are not river flies at all. They are still water ones, or they're found in very small water bodies. So I'd say, as I put in, it's worth recording any stage from small waters. The adults, you can fill in the gaps in a species list, but you've got to be very careful about the interpretation of the data. But no more than you have for Lepidoptera. In fact, we're very much better off than the Lepidoptera. If you run a light trap, you're going to get a lot of knotweeds with grass-feeding larvae. And you're going to look around the trap, and what are you likely to see around the trap? Grass. So where have those adults actually come from? Have they come from near the trap? Now the caddis, much better, because we know the basic biology of most of the larvae, then the origin of the adults can be suggested much better than for many of the insects whose food is, or potential food is, much more widespread. But you know, this was an example. Obviously it is from northwest England, where I'm now based. But right, the light trap was run at Risley Moss. The idea was it was the BioBlitz. Let's find out, you know, as much as we can, record as many species as we can from Risley Moss. The hope being that they would be associated with Risley Moss. But in fact, most of the caddis, when you looked at the habitats that were found, we've got 6 species of caddis now. 4 were not mossland specialists at all. They've never ever been found breeding on the moss. 1 was a specialist, but the likely habitat was probably there. Oddly enough, when you looked at the wind that night, there'd been gentle easterly, well, a moderate easterly breeze. It had been generally warm, so the caddis would be active and almost certainly been carried over from that. They might have come from there as well, but generally not from the one. 1 species was from a river. No idea where that came from. But it's a vagrant generally. I mean, there are vagrants, as there are in Lepidoptera as well. You do get these vagrants, especially on warm nights, and the breeze blows off the swamp. But of course, because it's in the night, you don't necessarily see what's going on, but they have been seen in the daytime as well. And then the final section, I'm just going to run over the identification guides. Larvae first. Okay, that's my key to this simple key. This does work on the assumption that there are characteristic cases for quite a few caddis, and certainly groups of caddis. And that's what this simple key was aimed to do. That you could get quite a long way with just a hand lens. Quite cheap, and there's a new edition being planned. We're taking the photographs for it at the moment, and that would be hopefully coming out 2023. Now, the good thing, the thing which has revolutionized the whole area of recording would definitely be mobile phone cameras. Because I can now ask for people to supply a voucher with a record. And it's usually easy, but caddis have a problem. The light bounce from the water and wet surfaces is a real problem which has to be overcome. But you can use this if you've got a microscope as well. This is Sharon Flint using a mobile phone and a microscope to get better pictures. So that's good, because you can then start to think about using a more sophisticated key. You might think, right, he said that we can get so far with a simple key, and that some of the others he had mentioned previously, you've got to really kill the larva. But do you have to always kill the larvae? Well, you can use soda water to anesthetize caddis. And once it's knocked out, then you can you've got about half a minute if you put it into fresh water. You can take it out of its case and look at it and then put it back. No essential, right? If you want to put it back, you've got to put it back when it's anesthetized, right? Because larvae, very few voluntarily re-enter the cases if they've left them. And you can use them, you can humanely kill them if you want to become a specimen. These are the two standard works, to caseless and case larvae. And they are written for people with good microscopes. And of course, they're all line drawings. I'm not planning a new edition of this. Somebody else, I think, is going to do that. There's some more basic species separations I do want to get done. I mean, I am now in my 70s, and it's wise to be at least realistic. You can go for modern photographic guides, but they are quite expensive. Adults, right? That's the standard book for adults. Peter Barnard and Emma Ross's Royal Encyclopedia, not too expensive. And with that, you can identify every species, apart from a couple which have just been added to the British list. And I think everybody who wants to seriously get into caddis caddis adults will be buying that book. It's a European one, but it's £160. Oh, here we go. I'm told that this is going to go on YouTube. So if it's on YouTube, you'll have to get used to adverts. So I thought I would beat them at their own game. So here is an advert. As I say, if you want to turn your life around, don't skip this ad. Are you losing interest in adult caddis? If so, this book can change your life. It's coming in early to 2022. And it's this, The Adult Caddis of Trichoptera of Britain and Ireland, by myself and Sharon and Peter Flint, one of the Aid Gap series. Don't know what the cost has been. It's going to be similar to other FSC guides. It's going to be about 100 pages. That covers all the species, but it's not good for live caddis or photographs of them. And the new guide is aimed to let any live British caddis adult or a photo to be put into a group. And in addition, 70 of them can be named from wing markings alone. Now that 70 out of 200 might seem quite a small number, but if you add an additional 90 can be named from the markings and genitalia examination, and many of the robust caddis can have that genitalia examined when they're alive or restrained in the tube. The genitalia of caddis are much more accessible than those of moths. For a start, they're not hidden away in under scales, and at the moment, there's very, very little done on the internal female structures. There probably should be a lot more, but at the moment, it's almost all external. And that will then leave only about 40 caddis, right? Who they're mainly the micros, and they're a bit fiddly, and you can't work to identify them easily. The way which we've got, it's a crude classification, but we've said if you can hold the caddis with one pair of forceps in one hand and use a hand lens or microscope with the other, then we'll cover it. If you need two pairs of forceps to manipulate it, no, it's too detailed, we're not dealing with it. Real crude separation. But anyway, it's well illustrated. The features are not, there's not a huge number of features to look for. Some of the techniques, particularly photographs, which the light bounce you get from the wings of caddis, which would be greater than that you get from a lot of moths. That is a problem in some identification. But we have groups. The groups are to a certain extent taxonomically based. In other words, we have a very spiny leg group, which is Phryganidae and Lymnophilidae. Group 2 with the long antennae are the Leptocerids. We've got a key to the major groups, but then once you get to a group, we then have a number of subgroups, and there's where we've gone just purely on wing markings to get to those subgroups. And we're not claiming any taxonomic relationship. Those groups, subgroups, haven't got any taxonomic validity, but we hope useful. And then when you get down to the species, we hope to have plenty of illustrations, particularly something like Limnephilus marmoratus, which is a very variable caddis. So that's the basically part of the key. We've got guidelines on netting from swarms, guidelines on how to anesthetize and look at an adult caddis genitalia when they're alive. We know quite a lot of people, when we sent out a test version, a lot of people were using this for dead caddis, which they've got a dead and dry caddis. So we show how you can prepare dead caddis. Again, it's so much easier than the moths. I mean, KOH, which you would use for moths, is a last resort for caddis. And that's what I would say. One holds the specimen, the other takes the photo. And this would be an example, the Hydrocycle, of where the adults are frustratingly look very similar. It's dreadful to tell them apart. It's one of the massive frustrations that one of the commonest caddis people get, you just have to say, is Hydrocycle. But the male genitalia, the male Ediagus, has a particular shape, and that features in the guide. Well, even when it gets down to the sort of really tiny caddis, we even go as far as yes, we have small brown jobs, but the great advantage of this new guide is they're not taxonomic, they're not scattered throughout the key. It's not like whatever family you get to, there will be some which are small and brown and nondescript, and most of them won't be. No, you're more or less the last group, our group 4 caddis, are ones which haven't got any features, and at the end of those are these small ones. But genitalia enables you to get quite a few of them. So, if you're motivated, are there any particular gaps in knowledge about Northeast caddis? Well, that might seem to be quite a decent map. Looks as though there is quite a widespread cover, and that's a lot of it is Environment Agency data, but there's a lot that we don't know about a lot of species. Places with particular potential, I think the Roman wall lofts, there could be quite a lot of interesting caddis species tucked away in those Roman wall lofts. When I was up in the Northeast, they were really very inaccessible. It was very difficult to to get near them, but they're much more accessible now. The other area that I think deserves more work would be the Durham Deans. Okay, the main streams of the Durham Deans have been thoroughly and utterly messed up, but the sort of sides, the springs and oozes from the side of those Deans could have more species in them than and there could be some rare species, because there are it's a site for rare species, that sort of habitat. Oddly enough, you might think, oh, up at Teesdale, wow, it'll have lots and lots. No, it was really disappointing. All I can think is that the sort of conditions which have enabled some of the Arctic alpine plants to survive didn't feature, it didn't really suit caddis, or that the caddis had been, of those had been, you know, was just too tough for them at the time that those Arctic alpines were hanging on. I would like to thank the recorders who submit stuff to iRecord, and I'm picking out two in particular, and it just shows an example of how, you know, the value of iRecord and the value of taking a photograph and just, you know, and just sticking it in. I doubt Philip Jordan thought that he got anything really unusual, but he certainly had. And that is it actually sitting on the bird net he had. Ian Fisher, finding that, well, Ian's put a lot of records into iRecord, and that just happened to be one of the more intriguing ones, as I'll show you on the map. I mean, look, there's Limnephilus decipiens, definitely moving north due to a warming climate, but there's that record there. Nearest to the one is Durham, and that was only about a year before that one there, and it certainly reached. They are, you know, I mean, it was 1970s. Its distribution would be probably something like about that, so it's moved up there. Leptoceras and Geneiformis always had isolated populations, but in general, it was mainly, certainly about there would be where it was. And then there it is up in Seg Hill, and now we've also had a recent one from the Newcastle area. So, you know, very interesting, both common species, but it's really interesting seeing these things spread. Some people might like giving the data straight to Eric. That's okay, because Eric's one of the good guys, because it puts a summary of its data onto the NBN, and also it abstracts data from the NBN. There are a few record centres who do neither, and, you know, well, they're not as easy for me as a national caddis recorder to deal with, but Eric's fine. And finally, as I've said, the final thing is, unlike many insects, observing caddis can face over winter when the main growth time of the larvae is. And the special one you want to go for, looking for, is this one, Glyphotelius pellucidus, the mottled sedge. If you look in pond edges, which have got a lot of dead leaves, you might see what looks like a very large leafcutter bee has been at work. You know, very, very big discs have been cut out of the leaves, and these are these perfect discs. Well, that's a perfect disc. That's such a good one, made by the larvae of the mottled sedge. It's fairly common in your area. It's one of the caddis which you can record to species just by looking in the water. You don't have to get your hands wet, but go out and have a look for it. It's a lovely caddis larva, and the interesting thing is, it tends to make its leaves, its cases out of leaves which are a bit difficult to digest and eat. So it'll make, say, its case out of the oak leaves, or beech leaves, especially if they're there, because beech is particularly indigestible and unrottable as a leaf. But it'll graze and feed on things like the sycamore, which are much softer and more palatable. And that's its distribution. See, so it's not abundant, but it's not in every square, but it's waiting for you to find. And that is the end of my talk. Okay. Right, Fiona.
Yes, Ian, or should I say, Mr. Bond, mission accomplished. So yeah, that was absolutely super. What an absolute feast of information there. Thanks for that, Ian. And I certainly feel inspired to get my wellies on and get out and do a bit of looking around, seeing what I can find. So now, I don't know, we've not had any questions come through in the chat, so I don't know if anybody unmute themselves and ask a question. We'd like to hear any of them. But I was wondering, how do people actually study them? Like, for example, you know, the sock sort of forming caddis, and the eating habits, how do people actually, you know, study what they eat and how they behave and what they do?
Right, well, a lot of the pioneer work of that was done by the person who supervised my PhD studies at Newcastle University, a man called Norman Phillipson, and he made stirrers. He had this marvelous setup. If anybody remembers Meccano, right? He used Meccano to make sort of, when he had an electric motor and pulleys and wheels, and he had stirrers, and that created the water current in small containers. And that was where he was able to then observe the behavior of those. He was then followed by a student called Phil Boone, and he had a flume. In other words, he had a perspex channel made, and water flowed in at one end and out at the other. And he used astroturf as a sort of false moss, because it was a good place for things like the hydrocycles to then go and build their nests, their nets. And it was from them that we worked out what the current optima were for these species. You observe their feeding, you observe their behavior. You can do all sorts of things in an artificial flume. And you realise one of the other things about the hydrocycles, which is very intriguing, is they live very close together. All these caseless ones are very closely grouped. In other words, you've only got the perfect water flow really in any, it's a small part of the bottom. So you've got to get in there and you get group together. So there's a lot of competition for these places. So big larvae will tend to try and move into the shelter of another one. So the squeak, they actually stridulate to try and which lets the caddis coming in know how big the caddis in the existing shelter is, and also what species it is, and whether in fact it's a good idea to actually try and break in or not. Because if you do and you fail and you get caught in the net, you'll be cannibalized. So they describe these sort of roving ones are well described as desperados. I think that's probably the best description I have of them. There was, yeah, it's you probably won't succeed, but it's worth a try.
Wow, it just gets more interesting and more interesting. Let me just check in the chat. So I think, yeah, lots of people are just saying how interesting it's been, and looking forward to the new guide as well. But yeah, so I don't know, does anybody want to ask a question? Or I think you've been pretty comprehensive in your coverage there, but we don't seem to have any questions. But so yeah, just just more thank yous. We can have a quick look at the chat at the end, just so you can see people have really enjoyed it. So I think I'll just wrap up.
Can I just say, right? Okay. I mean, I haven't actually put my contact details there, right? But I mean, I'm happy for when you put this out as on the YouTube, you can certainly put my contact details on there. And from that means that should anybody want to ask any questions, obviously, I'm the recording scheme organizer,
Yeah. Yeah, but I'll do that. I can do that when I sort of do the video. So, and yeah, that was, thanks for just putting in. It just shows, really demonstrates the importance of recording. So, and how we're in a great position here to, just as things are starting to change and move north, we can really like the 2 records you showed, that something quite sort of interesting happening. So
the article, I mean, the caddis are not a group, because they're mainly nocturnal. Then we haven't had the sort of dramatic increase in distribution that is noticed for the Orthoptera and the Odonata, which are principally daytime insects and can really benefit from the extra warmth. But it still is happening. I have to say, I mean, the northeast isn't. It's why I mentioned those 2 sites, because in general, I've had to say, if you say, well, what would people from the rest of the country go to the northeast to see in terms of caddis? And the answer is nothing. There isn't any species you would go especially to. Malantarn, different, right? Okay, but that's not really in your area, sort of more northwest, isn't it? But at the moment, there's nothing, particular where people would sort of divert to go and see in the northeast, and that's mainly because you haven't got a lot of very large lakes. I think that's one of the features. You haven't got a lot of exposed limestone. It tends to be clotted over with this horrible clay. So that's one of the reasons that you just don't have as many of the really unusual species which you'd find elsewhere in the country. But all the same, there's still plenty of gaps to be filled in. But as I say, I just have this feeling that if somebody really concentrated on the Roman wall lofts, we could actually start finding species which are known, certainly from sort of Scotland. I would think, and it could be the last refuge of some of the northern species in the northeast.
All right. So well, hopefully some people will be inspired by this to get out there and have a bit of a look. Do send your records in anywhere. We always say, could be to us or to Ian's recording scheme. The main thing is just doing the recording somewhere. So
I mean, we are now. I mean, if I can put a plug in, let's say, for iRecord, and several people prefer iNaturalist, but the great thing is now, and it is really important, everybody knows this now, the links between iNaturalist and iRecord are much better established. In other words, records which are put into iNaturalist for a long time, they weren't available to iRecord and thus not available to the NBN. That has now changed. Records which are submitted to iNaturalist with the suitable license allowances on them, they will then end up on the iRecord, will be verified and get through to the NBN. And it's always something which is a recording scheme. I prided myself in our assistance. We try to make sure that there is not a backlog. I know the problem for iRecord was some people had huge backlogs. You put a record in it would be months, or if ever you got a response. We on the Caddis Recording Scheme try to for records to be sitting around waiting to be verified for no more than about a week or so. Yeah. So and the great thing is, because Paul takes records off the NBN, right? They are available to Eric via that route. By you putting records into iRecord and iNaturalist, it doesn't mean that they're not available for use by Eric. It's all part. I mean, it's we are getting there in the recording system of interchangeability. It's some time, but we are getting there.
Yeah, it's improving. Yeah, so Right, Abby's just saying she's got a short video of a cased one, so we'll maybe connect. I'll be able to connect you and Abby up when I send an email, and she can probably send that through to you.
Yeah.
So yeah, I think we'll let everyone get on. Just want to say thanks very much, Ian. That has been absolutely fascinating. So I definitely feel inspired to get out and about. And thanks everybody for joining the talk. I'm just thinking maybe we could organise a wee walk, depending on you know, what we can do in the next few months. But if I got anything, thought about maybe just having a little meeting or a walk somewhere, I can contact everyone. I've got the email addresses via the booking. So
yeah, it is a good time, honestly. You know, as I say, you know, the ponds and lakes and lake margins where you get this sort of leaf litter, that is where you will now start to get a lot of these caddis flies. Now, I have to say that they're going to be very difficult to get to the species. Because you know, you have to look at the larvae, and then they tend to be the ones which make rather generalized cases out of the bits and pieces. But everything I say about the caddis, you know, I mean, you don't have to name it to a species to actually see it as the very interesting animal it really is, you know.
Absolutely. Right, I'll let everybody get wrapped up and just leave the talk if you want to. So just thanks everyone, and thanks Ian. That's been super. So I'll just stop the recording now.